Hey there. In today's screencast lesson, we'll be talking about the geologic time scale, the very thing that we use to categorize the events of Earth's history. So, how do we come up with the geologic time scale? In other words, what do we use in order to figure out the events that have happened and the organisms that lived around the Earth when, well, ancient times, millions and billions of years ago? The way we come up with that is by studying the evidence found in the rock record. If you remember, when we talked about sedimentary rocks especially, as sedimentary rocks are the most important to tell us some of the evidence of what happened during Earth's history, is sediments record the environment that was around in the Earth at that time and that place in Earth's history. Not to mention, remember, sedimentary rocks are the only ones that contain fossils. Now, metamorphic and igneous rocks are also very important because they can help us find more or less exact ages of geologic history. And thus, when we take all of that information and put it together, we can figure out the events that have occurred in order from the Earth's past until today. So the definition that we have here is the geologic timescale is simply a record of the Earth's history from the very beginning, its origin, about 4.6 billion years ago, to the present day, today. Now, I want you to think of the geologic timescale as more or less a timeline. All of you have probably made a timeline as a project at some point in your school, most likely in a history class where you take the timeline of an important historical figure, and then we break that timeline down. Usually we begin with the birth of that individual, and then the timeline typically ends with the death of that individual. Now, fortunately, the Earth has not died, it's still around, so we continue to record the events that have occurred, and who knows, maybe the major events that we experience today, for instance, a super volcanic eruption, may perhaps kick us into the next segment of time on the geologic time scale. Who knows? That's generally going to be left up to geologists in the future to determine. But again, think of the geologic time scale as simply a timeline. However, the big difference between a timeline that you'd be familiar with is that we're including 4.6 billion years of the Earth's history. So it becomes a little bit more complicated than breaking down the life of, let's say, Ben Franklin or some other important figure. So here we have the geologic time scale. We have it broken up into several different segments. What you'll see on the right-hand side here is that they've zoomed in to just the most recent 540 million years. So you'll notice this scale is in terms of millions of years. So remember, 1,000 million years is equal to a billion. So that's where we get back to about 4.6 billion years at the bottom of the scale. So again, the bottom represents the oldest events of Earth's history. The top represents the most recent events of Earth's history. And as you can see, with the latest 540 million years, we're able to break it down into some more specific subdivisions. So I want you to think about it like this as well. When we typically think about the events in our lives past, we typically break a year or our life down into different subdivisions to help us to remember the events that have happened a little bit better. So you're now 15, 16, 17 years old. It's very difficult to remember the exact date and time that something happened when you were, let's say, 5 or 6 years old. But instead, you may remember, well, that happened during elementary school years. So there's where you might break down our life into something like a subdivision, similar to how we break down the geologic time scale. So here are our 4 major subdivisions of geologic time. You see they're broken down into subunits based on chunks of time. So if we look at the last 4.6 billion years of Earth's history, and we want to break it down into the largest subdivisions. So if we think about our lives, maybe we break them down into the periods of time that represent how long we've been in school, elementary school versus middle school versus high school. Well, then you might compare that to eons, which represent typically billions of years of geologic history. Then we have the eras, which are broken down, the largest of which are a few billion years. But then typically the eras of the more recent time are broken into 100 million year segments. Periods are generally in terms of tens of millions of years, and then our epochs, which are the smallest subdivision of time, are broken up into hundreds of thousands or millions of years. Now, as far as eons are concerned, we have 4 major eons that we break up geologic history into, and you can see their descriptions. So the earliest stage was the Hadean. That's when the atmosphere was developing. That's when the Earth's crust was cooling and solidifying. And we also had the formation of the oceans, but no life existed during the Hadean eon. And that lasted about 4.6 to approximately 3.8 billion years ago. Then about 3.8 billion years ago, something remarkable happened. We saw our first bacterial life forms on Earth. Those bacterial life forms were around for about 1.3 billion years. They continue to be around to this day, but about 2.5 billion years ago, as you see, the Proterozoic began, and there we have the appearance of more complex life forms. Now, the Archean with those earliest bacteria were very important because they actually added oxygen to our atmosphere. It's pretty important for us today. Now, going back into the Proterozoic right here, okay, we see the first appearance of more complex life. When we say more complex life, we're still not talking about things as complex as this guy right here, or apes, or dolphins, or whales, other intelligent creatures. We're talking about just simple multicellular life. At the end of the Proterozoic, about 540 million years ago, an earthworm would have ruled the planet. That's how complex life was. Not very complex. Then we enter into what's called the Phanerozoic. This is the time period in which there was abundant life on Earth. We had life in the oceans to begin that time period, but it ends with today, where we have life all over the planet, not just in the oceans. And that only represents, and I know it's weird that I say only, but it represents only the last 540 million years. So things looked quite different for most of the Earth's history than they did today. So let's take a look at the eras. All right, now the eras are the next subunit. If we take eons, we break them down into eras. So again, if I could give you a comparison, let's say we take, you know, uh, recent history, recorded history, we can break it down into centuries, which are 100 years, pretty big subdivision. Then we can break them down into decades. So again, we're just basically breaking down the segments of geologic time or the Earth's history into smaller subunits. So eras are the next big subunit, and they're basically named after how complex life forms are. Now, one thing you'll notice with the geologic time scale that we have over here, let me go back to the original I showed you. Notice that we have, in terms of eons, we have them broken up. We have the Hadean, the Archean, Proterozoic, and Phanerozoic represented here. But when we talk about eras, notice this one right here, the Precambrian. When we talk about eras, we take the entire first we take the entire first 4 billion years of Earth's history, and we just simply call that the Precambrian era. Why? Well, that's because we didn't have significant multicellular life at that point. So when we talk about eras and the complexity of life forms, it makes sense to lump the first 4 billion years into one subunit. So that's why we have the Precambrian. We have the earliest life forms, and you see it's not even represented on this geologic time scale. So we begin with the Paleozoic. All of these, you'll notice, end with the word zoic, and that word comes from zoo, or life forms. When we talk about the Paleozoic, we have the most ancient life forms. So paleo means ancient life. And so we had everything all the way up until the age of the dinosaurs. So here we saw the appearance of creatures with shells. Then we had creatures that could actually swim in the oceans, creatures that looked a lot like squids if you're around today. Then we had things that looked a little bit like lobsters. And then around the middle of the Paleozoic, we actually had the first fish. Then we also saw the first land plants. Then we also saw the first land animals, which were just insects, so a lot different than what you think of today. Then we had our amphibians, things like froggies, and also reptiles at the very end of the Paleozoic. Reptiles ruled the earth at the end of it. Now, most of you probably think of the extinction of the dinosaurs as being the most significant, but look here. At the end of the Paleozoic, more than 90% of all life died. That was the most significant extinction that ever occurred on Earth. In fact, some scientists think that almost 95% of all organisms on Earth died. It's the closest the Earth had ever come to having life completely snuffed out on the planet. Pretty crazy. Then we get into the dinosaur age, the Mesozoic, okay, middle life. This is the age that's the most romantic. Jurassic Park, of course, is one reason why. But the Mesozoic is what includes the dinosaurs. And of course, at the end of the Mesozoic, those dinosaurs became extinct, which is important for us because this ushered in the age of mammals. Us, right? So dinosaurs becoming extinct paved the way for mammals to become the most dominant organisms on Earth. And so for the last about 65 million years, we've been in the Cenozoic era. And we can take the eras and break them down into time periods. Now, time periods are a little different because they're a lot more specific. They include only a short, well, I shouldn't say only, they include a smaller period of time so we can be more specific with the things going on during a time period. They're defined by the organisms that lived and died. So over here on the right, you can see some very important organisms that evolved during that time period. And then some individual species of those organisms may become extinct. And that is what marks the end of a geologic time period. Okay, now remember, we're not talking about mass extinctions. Animals unfortunately go extinct, gosh, nearly every day today on Earth. So we're not talking about the extinction of a significant number of animals. A mass extinction is one defined by 35% of all life on Earth being extinct. So when we say a period begins and ends with the extinction, we're talking about a common group of animals that happen to live during only that specific time period. When they become extinct, well, in rock layers, we see the existence of that animal in the lower part. Then we see those fossils throughout the rock layers. And then when we don't see those fossils anymore, well, what does that mean? Correct. It means that those organisms have become extinct and they're not around to leave their fossils behind. Now, the names we come up with the geologic time periods, they're actually named after geographical locations where we happen to find a lot of rock evidence, or perhaps the first rock evidence of that geologic time period. So when we call a geologic time period the Mississippian, please understand that that's not, we're not saying that only the Mississippi area is where we find the evidence of that time period. It just happens to be the first we found it, or perhaps it contains rocks that have a lot of information. So like the Jurassic. Jurassic is named after some mountains in Eastern Europe where we find a lot of fossils for the evidence of what happened. Now we come to the last subdivision. Here in a moment, I'm going to ask you to pause this video and I'm going to ask you to answer the question why and type it out in the Google form. But we have the most specific and detailed record of the epochs that are the most recent 60 million years. Now remember, with the rocks that we have on Earth today, erosion is getting rid of them. Remember that new rocks form on top of old rocks, so older rocks are usually buried deeper within the crust. So what I want you to do is think for a minute why those couple of things are significant in allowing the most recent epochs of geologic time. For instance, the last 60 million years or so. And remember, humans have only been around for the last 100,000 years. So humans have not been around for a significant portion of Earth's history. And in the activity that we're going to do in the next couple of days, hopefully that will sink in. So I want you to pause this and answer the question why. Why do you suppose we have the most detail of the last 60 million years? Now that you've answered that question, here's one answer. Weathering and erosion have had more time to erase the record of rocks that are much older. For instance, the glaciers of the last ice age have completely eroded away rocks that contain any evidence of the dinosaurs in the Midwest. Those rocks are now ground up in chunks and part of the soil and as sediment, so we'll never get any record of what was going on during the age of the dinosaurs in the Midwest. Another reason is because the older rocks are usually found further deep within the crust and they're just simply harder to get to. So that was an introduction into the geologic timescale. And make sure you answer the questions on the Google form and turn it in or submit your homework so you get credit for it. Thanks, guys.